Very good morning, student. I think you all are safe and healthy in this COVID situation because you stay at your home. Do not go anywhere. Okay. By using our video lecture, we are discussing the subject of power engineering and refrigeration. This is our second lecture on the unit number 1, that is internal combustion engine. We just take some recap or preview of our first lecture. In that lecture, we are introduction of heat engine. Okay, what is heat engine? Heat engine is a device which converts the chemical energy into thermal energy, and this thermal energy is to perform a useful work, that is heat engine. There are the two types of heat engine. First one is internal combustion engine and second one is external combustion engine. In internal combustion engine, the combustion of fuel takes place inside the cylinder. Okay, this is called as internal combustion engine. And external combustion engine, in external combustion engine, the combustion of fuel takes place outside the cylinder, not inside the cylinder. It is called as external combustion engine. And we also see the advantages of IC engine and application of IC engine. Now, in second lecture of unit number 1, internal combustion of IC engine, the contents are classification of IC engine and terminology of IC engine. Now we will move the classification of IC engine. The first classification of IC engine are according to the working cycle. Okay, now working cycles are subcategory. First one is Otto cycle, second one is diesel cycle, and third one is dual cycle. The Otto cycle is also called as a petrol cycle. Okay, now we will discuss in our next session for briefly these cycles. Next classification is according to the method of ignition. First is spark ignition and second one is the compression ignition. The spark ignition is offered only in petrol engine and compression ignition is offered only in diesel engine. Okay, now third classification is according to the fuel supply. The fuel supply by using carburetor system or by injector system. In the carburetor system, the fuel is mixed with the air and then it will supply to the engine. Okay, in injector system, we will just compress the air in the cylinder. Okay, at the end of compression, we will use injector for eject the fuel. Okay, the carburetor system is used in a petrol engine and ejector system is used in a diesel system. Next classification is according to the method of cooling. Okay, the first method of cooling is air cooled method and second one is the water cooled method. Normally their two-wheeler vehicles are air cooled and four-wheeler vehicles are water cooled. Next classification is according to the number of stroke per cycle. Okay, first are 4-stroke cycle engine and second is 2-stroke cycle engine. Okay, 4-stroke, there are the 4 stroke. First stroke is suction, compression, expansion and exhaust. These are the 4 stroke. Okay, and in second stroke engine, the first stroke is compression and second stroke is power stroke. The 2-stroke suction and exhaust, these are mixed with this 2-stroke. Okay, now we will move to our next classification. The next classifications are according to the type of fuel used. Okay, there are the 3 types of fuel we can use in IC engine. First one is petrol engine, second one is diesel engine or oil engine, and third is gas engine. We are familiar with this type of engine or fuel system. Next is according to the number of cylinder. First one is single cylinder engine and second one is multi-cylinder engine. Okay, generally in our two-wheeler there are the single cylinder, but we are using multi-cylinder engine our four-wheeler vehicles. According to the speed of the engine. Okay, that is first is slow speed engine, medium speed engine and high speed engine. And last classification according to the arrangement of cylinder. Okay, vertical cylinder engine means cylinder is vertical. Okay, second is horizontal engine means cylinders are horizontally. Next is radial engine, we will in next slide. This is called as the radial engine. Okay, in radial engine there are the number of cylinder and the crank will be rotated in circular manner and piston will be reciprocating horizontally. This is the radial engine. Next one is inline multi-cylinder engine. Inline multi-cylinder engine means cylinders are parallelly mounted side by side of the one cylinder. Okay, this is called as inline multi-cylinder engine. And last classification is V-type multi-cylinder engine. V-type multi-cylinder engine are shaped like this V shape. Means piston will be reciprocate in this direction and in this direction also on same crankshaft. Okay. Now, here the classification of IC engine is completed. Now we will move to the terminology of IC engine. What is the terminology? Terminology is the term related to the system that are explained. Hence, it is called as the terminology. Now we will move to the IC engine terminology. The first terminology of IC engine is cylinder bore. Bore means drill. Okay, bore means internal diameter. Okay, cylinder bore. The internal diameter of cylinder of an engine is called as the cylinder bore. As per indicated in the diagram, there is indication of bore. Bore is nothing but the internal diameter of the cylinder. Okay, it is denoted by small d. Next is top dead center. Top dead center means the extreme position reached by the piston at the top of the cylinder. Means piston will be moved in upward direction and extreme position to reach by the piston at the top of the cylinder, it is called as the top dead center. As per shown in the figure, there is the top dead center. Next is bottom dead center. What is the bottom dead center? When the piston will be moved in downward direction and extreme position reach at the bottom of the cylinder. At the bottom of the cylinder, it is called as the bottom dead center. Okay, means cylinder has one top dead center, means piston will be reached at the extreme top position and piston will be moved extreme bottom position of the cylinder. It is called as the bottom dead center. Okay. Next one is the stroke length. What is the stroke length? This is our piston top dead center and bottom dead center. Okay, sorry, cylinder top dead center and bottom dead center. When piston will be moved from bottom to top dead center, okay, when piston will be moved from bottom dead center to top dead center, then this distance is called as the stroke. Okay, what is the definition of stroke? The normal distance traveled by the piston in cylinder between the extreme upper and lower position of piston is called as the stroke. Okay, now next is the swept volume. What is the swept volume? It is the volume that piston movement from BDC to TDC. As per shown in the figure, there is given the swept volume. When piston will be moved from BDC to TDC, then volume occupied between this space is called as the swept volume. It is denoted by V suffix C. Next one is the clearance volume. What is the clearance volume? It is the space in the cylinder when piston is at top dead center. Okay. Now, when piston will be moved up to the top dead center, when above the volume of top dead center, remaining volume or space above the top dead center, it is called as the clearance volume. It is denoted by V suffix C. Next volume is total volume or cylinder volume. What is the cylinder volume? It is the sum of swept volume and clearance volume. As per indication of the diagram, total volume is nothing but the swept volume and clearance volume. Okay, swept volume and clearance volume, it is called as the total volume of cylinder. It is denoted by capital V. Next is the compression ratio. What is the compression ratio? Okay, what is the compression ratio? It is nothing but the ratio of maximum cylinder volume to the clearance volume. Okay, it is the ratio of maximum cylinder volume. Maximum cylinder volume means total volume, Vs plus Vc. Okay, and clearance volume, it is denoted by Vc. Okay, compression ratio, it is denoted by Cr or R suffix C. Okay, the other definition of compression ratio is volume before the compression to the volume after the compression. Okay, means volume before the compression, this is our compression. Okay, volume before the compression and volume after the compression. When the ratio of these both value, it is called as the compression ratio. V1 is the volume before the compression and V2 is the volume of after the compression. Next ratio is the expansion ratio. Okay, before that we know about the compression ratio of petrol engine is 5:1 to 10:1, and compression ratio of diesel engine is 12:1 to 22:1. Okay, why the diesel engine has the higher compression ratio than petrol engine? Okay, the petrol engine has provided the spark plug. Okay, by providing the spark, then fuel will be burned. When compression process will be at the end. Okay, when the complete the compression process, at the end of compression stroke, there will be spark provided by the spark plug and combustion process will be occur. Okay, but in diesel engine, the compression of air starting. Okay, at the end of the compression stroke means air will be fully compressed. At the end of the compression stroke, by fuel ejector we can eject the fuel in the form of spray. Okay, this fuel will be mixed with the compressed air and it get automatically burned due to the compression. Okay, hence the diesel engine has the higher compression ratio. Okay, next is expansion ratio. What is expansion ratio? Expansion ratio is defined as the ratio of volume after the expansion to the volume before the expansion. Okay, it is denoted by R suffix E. Okay, V4 divided by V3. V4 is the volume after expansion to the volume before expansion. Okay, understand all the terms related to the IC engine. Now we are moving to the working of four-stroke engine. Working of four-stroke engine, there are the two types. First one is the spark ignition and second one is the compression ignition. Now we will move to the spark ignition engine of four-stroke. This is the four-stroke spark ignition engine. We can identify the different components of four-stroke spark ignition engine are cylinder block, piston, connecting rod, crankshaft, cylinder head, intake valve and exhaust valve, cam and camshaft, valve spring, spark plug. By using spark plug, we can identify this is the spark ignition engine, cooling water chamber and crankcase. Okay, now working of four-stroke SI engine. This is of working of four-stroke SI engine. Actually, what should be done in four-stroke engine is completed the two revolution of crankshaft. The below part that is circular moving is called as the crankshaft. Okay, this crankshaft will be moved two complete revolution, then it is called as the four-stroke engine. Okay, each stroke contains 180-degree revolution. Okay, therefore the cycle consists of 720 degrees. In the four-stroke engine, there are the four-stroke occurs. These are the four stroke. First stroke is the suction stroke. Okay. Second stroke is the compression stroke. Third stroke is the expansion or power stroke, and last fourth stroke is the exhaust stroke. We can see this stroke one by one. Then first stroke is the suction stroke. What should be happen exactly in suction stroke? Okay. Piston from top dead center will be moved downward direction. Okay. When piston moves in downward direction due to the rotation of the crank in clockwise direction, piston moves downward direction. Above the piston area, there will be the vacuum will be created in the combustion chamber. Okay. At that time, air fuel mixture will be in the carburetor is higher pressure. Then it will be flow from inlet valve into the combustion chamber. Why? Because outside pressure is the atmospheric pressure and inside pressure is the vacuum pressure. Then the air fuel mixture easily flow into the combustion chamber when inlet valve will be open. Now piston will move downward direction and fresh air will be admitted into the combustion chamber. Okay, when piston will be reached at bottom dead center, then this combustion chamber is fulfilled with the fresh charge coming from the carburetor. Now in next slide, there is the compression stroke. What should be happen in compression stroke? The first stroke is the suction stroke, that is 180-degree revolution of the crankshaft. Then next 180-degree revolution of crankshaft will be occurs compression stroke. When piston will be reached at bottom dead center, in the combustion chamber there will be the fresh charge is admitted. The piston will move from bottom to top dead center. Okay. Now when piston will be moved from bottom to top dead center, at that time both valves, means suction and exhaust valve, are closed. Now piston will move upward direction, then fresh charge will be compressed. Okay, fresh charge will be compressed. At the end of the compression stroke, the spark plug will be produced the spark. Okay, at the end of the compression stroke, spark plug will be produced the spark and will get burned. Okay, now this is our third stroke. What exactly happen in third stroke? When piston will be come at the top, at the end of the compression stroke, spark will be produced. Due to this spark, okay, the fresh charge will be burned. Okay, now the power developed inside the combustion chamber, then burn gases will apply the pressure on piston and piston will move to downward direction. When piston will be moved downward direction, okay, that is our power stroke, and this is we will see in the our turning movement diagram. Okay, the power stroke is maximum power generated during the power stroke, and other three strokes are consume the power from the power stroke. Okay, at that time both the inlet and exhaust valve are closed. Now our fourth stroke will be start. Okay, that fourth stroke is the exhaust stroke. What exactly happen in the exhaust stroke? Now when the due to the force applied by the burn gases, piston will be moved downward direction. Okay, now piston will be moved again upward direction due to the movement. Okay, due to the momentum of the power, piston will again move in upward direction. At that time exhaust valve will be open and all the burn gases inside the combustion chamber are pushed out to atmosphere through the exhaust valve. This is our fourth stroke. Okay, now actual animation we can see. This is our first stroke suction, this is second compression. Okay, orange color will be indicate our suction stroke. Okay, suction occur after that compression. At the end of compression, spark plug will be produce the spark and gases will be burn out, and these burn gases will apply the pressure on the piston. Okay, that is our expansion stroke. This is our expansion stroke. Again piston will be moved in upward direction. At that time piston will be in upward direction, exhaust valve open and all burn gases are sweeping out to the exhaust valve through atmosphere. This is our actual working of 4-stroke SI engine. The compression ratio of petrol engine is 5:1 to 10:1. It is very necessary to maintain this compression ratio. Okay, we have already seen the what is the compression ratio. Okay, thank you. If you have any queries regarding this video, you just mention your queries in comment box. Thank you very much.